this is an area when we talk about glaciers, and you don't get much opportunity to look at what we're talking about when we talk about glaciers. And so I figured I'd use this opportunity today to do that. It's a little windy to do anything down by the river. I tried videotaping earlier, and the sound quality is terrible. And I'm not sure that this is all that great either, but hopefully you can hear me pretty well. All right, so this is an area where, a couple million years ago, the glaciers had come down and dragged all the material down to this location or this area. And when the ice melted back, just like if you were to put a bunch of different particles of soil and sand and rock and things into an ice cube and freeze it and then thaw it out really quickly, all that material would drop straight down. And it would be unsorted. So there wouldn't be, small particles, large particles falling out first like you would in a stream. And then as you get progressively slower, as the stream slows down even more, you get your sands, your silts, and then finally, if it's a lake or a shallow area where the water's not flowing all that much, you get the clays and the silts to sit down. And those formations, when we talk about deposition, erosion deposition, and formation of sedimentary rock layers, the sand particles that fall and settle and that get compacted over millions of years, that's going to be sandstone. The silt particles, it's going to be siltstone. And the clay particles will eventually be shale. And I showed you a couple of shale banks in previous classrooms. Today, I'm in an area where, like I said, it's kind of a not necessarily a terminal moraine, but an area where a moraine or the ending of an ice, basically an ice sheet, has dropped all the material down unconsolidated and unsorted. And so what it creates is a rock called conglomerate. And conglomerate is a mixture of all different rocks and stones and things that have been cemented together and create a rock. I'm going to flip this around real quick. I want to show you. So this is the area I'm standing in. You can see a lot of this has been dug out. This is great stuff for drainage and areas where they want to put, this kind of river stone, I guess you would call it. And if you notice, all these particles that are in this rock, right? All these particles are, all different sizes, but they're all rounded over, which means at some point in time, right, they were in a stream. If they were more angular, right, then you would say that it was probably not a stream. It was more of something that just fell straight down from a cliffside after being weathered or something like this. But this has been dragged here, brought here through glacier activity. And you notice, like, they're all different particle sizes. Now, there's some smaller stuff that has come off the top that is not cemented together. But I'm going to show you, and actually, I'm probably going to steal this piece. But you can see evidence of the cementing that goes into this. And I want to take this rock here. I want to show you because it doesn't look very strong stuff, but this is pretty strong, right, to break this up. And this is not cement, like, cement that you'd see on a sidewalk. This is calcite deposits that have settled down into the rock and created these rock sections. And so they've dug a lot of this out. The loose stuff they've dug out. This hard stuff they haven't. I'm going to walk around a little bit. You can see all these stones down sitting at the bottom that have frost cracked off of here. From this conglomerate. I'm going to take this piece right here and stick it in my pocket right now. But I'm going to walk along, see how they've been digging out the sections here. And like I said, this river stone, I can't go that way, it's wet. This river stone here is good stuff. It's good landscaping stuff. It's good stuff if you want to use it for roadways or compaction of roadways. Underneath that, sometimes people use it as drainage, to fill in areas. It's good fill. So they, dug a lot of this stuff out. But I'm going to go over to this section over here. There's a couple more towers of this stuff where it's so hard they really couldn't break it loose. Obviously, with the growth in here, you can see that they've stopped using this. They've stopped using this section. gonna walk over here. Hopefully that wind's not worse over here. But you can see, right, these sections of rock, they're above me. And, oh, what the heck, I'm gonna take a chance. Not that that's a big chance, but last thing I want is that thing falling down on me. But you can see I walked right directly underneath this. So this is a big section where, you know, particles have fallen out of here, you know, mass movement since, you know, the weathering occurs in these sections. When you get the water inside here, inside these pieces, eventually what happens is it expands and it blows it open. And, you know, that's physical weathering. And you can see that. And a lot of these stones, like these stones aren't good to make a fireplace out of, even though you might think they would be. The problem with these stones is they have a lot of water in them. So, like when you put them next to a fire, they crack and they splinter pieces off. So you really don't want to, you know, while they would be great for a fire, you know, to make a fire pit out of, you know, some of these larger pieces down here. Great fire pit out of, it's not probably the best idea because of the water content in these rocks. But you can see, I mean, this has been, you know, how high this is over my head. This has been dug out pretty deep. I'm going to walk over to this one over here too. But as you can see right here, evidence of that cracking, right? These pieces, they just fall right off. You know, they're just, you know, this is a pretty decent rock, and the pieces just fall off of here. But again, all through this section, let me go over to this little spot over here. Nice if I can find one where there's a windbreak. But you can see how the layers are laid down. Here's a section in here, right, where you can see a little bit larger stone here, and then it breaks down into the smaller ones down below it. So it's almost like a layer in there. And as I move around, you see that same layer, right, kind of make its way around. So there was a point here, right, in history where maybe water was running out of the ice and it was washing away all the smaller particles in this layer right here. And you can see it's not as calcified either. So it's not it's not as hard. I mean, it's still, you know, some of the stuff is really loose. So some of the calcium deposit has moved away. But this stuff up here, I mean, you know, that's hard stuff. And that's probably why they haven't taken a couple of these big pieces out. But also, right, here's a piece of, if you look at this, I don't know if you can see this in here, right? This is like this must have been like a little eddy that slowed down just enough to create that layer of clay, or that section of clay, and it's created shale in here. So that's a pretty neat thing right there. As far as you know, geological history goes, that's kind of a neat feature inside of this section of rock where there must have been some kind of piece in there that shallowed out that was allowed to, or maybe a bigger rock over here, right? And it created that little slow spot in there where that clay settled. But you can see, you know, these are towering quite a bit above me. Here's a couple of spots where, you know, we talk about mass movement or movement of large particles due to gravity, right? Again, up here, you can see the shelf hanging, right? This section here, and it has broken away and dropped straight down into this area down here. And eventually, this will all weather away. But you can see in here, let me up in here. You can see up in here where, right, there's again that larger vein of bigger stones that seem to be a little bit more washed out than the others. And then up above it and down below it, you can see there was a lot more cementing that occurred in there. Um, it doesn't appear to be metamorphosed. So, most of this rock in here is definitely cemented together. You can see here's a section where probably the wind blows through here, so it's broken up a little bit more of the material into smaller pieces, and it's dropped a few off the top. Here's another section of smaller particles that are, cemented together, and obviously you can see, oh, there we go, I got some of it. But very, very hard stuff. This is not, if you look, let me see if I can zoom in up here. My God, it's hard to stand on this ground. You can see there's the calcite deposit. The calcite deposits along the outside edges of these, where there were rocks hooked together, cemented together by that. Okay, this is, by the way, if I didn't tell you, of course I didn't. I know I didn't. This is down, I don't know if you're familiar with, like, the Rotterdam Junction area. On Route 5, there's a Stewart's. And, I don't know, maybe 2/10 of a mile down the road. You don't really see it if you're not looking for it. Of course, my geeky earth science mind, this is all I do. That's all I think about. This here it's on the left-hand side going towards like Scotia on Route 5, but just past the Stewart's, maybe 2/10 of a mile down on Route 5 in Rotterdam Junction, this is where I am. I'm going to go around the other side here because the wind's blowing pretty good. You can see they were still digging out here for a while. But again, the same type of thing over in this area. Oh, here's a, let me get down in here because here's a little bit more finer particles with sand in it. So this section here, I can't break it off even, but there's more smaller particles and sand that are coming out of this. And if you look at this layer, you can see the difference between this up here, right, and this down here. You can see that sand like vein basically that runs kind of like this down through here, where the separation between layers occurs. Another vein of larger particles here. But again, this is still unconsolidated, unsorted material that was dropped millions of years ago by basically the end of a glacier period, as the glaciers were melting back. Obviously, the glaciers had moved much further down New York State, so while this area had ice, it may have stopped for a little bit, stopped melting for a little bit, and then began melting again quickly, and that's why this stuff dropped out like this. But all this material, right, large and small, is all dropped out all at once, and that's why it's unsorted. If a stream does this, if a stream were to lay this stuff down, then it would be sorted out. As the stream slows down, the larger particles would sort out first, and then as you move to slower and slower water, the smaller particles would move out after that. But here's a tree growing basically right into the side of this over here. So you can see they haven't touched this in a while. And that tree's at least 4 or 5 years old. But you can see again, this happens in freeze thaw. These rocks, like I said, they have a lot of moisture in them. That's why you don't want to use these around a fireplace, because the heat from the fire will bust them right open and send those hot pieces of rock at you. And obviously, I'm telling you because I've experienced that before. Do you guys have any questions about anything that I'm doing down in here? Or any questions about the area? You don't have to be shy. Again, here's that other platform I was looking at. It's kind of windy in the open. I honestly don't even know if I'm blocking them. I'm trying to block the microphone, but I can't even tell if I'm doing that. Now the sand in between is just blown sand, you know, the soil and sand material. That's just stuff that's deposited here after the fact. Some horsetail in here. Not an actual horsetail, it's a weed plant called horsetail. If I find another section of it, I'll show you. But yeah, this is the most impressive set of tower. You know, that's, I would say that's 15, 20 feet up easily. This section here is tilted up at an angle, right? Tilted up at an angle. Now that could have been just because this pass, like this was probably connected. If I could get up higher, I could tell, but this was probably connected between these two. And then it was dug out underneath and it just fell. But you can see this section here has fallen apart. A little bit of frost cracking right there, cracked that whole piece. But this is some of the larger conglomerate sections in the area that I've found anyway. There are some unique rocks that are in here as well. Because it's not all, like these rocks don't necessarily all have to be sedimentary. They could be from wherever. And for instance, I'll show you this one. If you look at that, that's got some very distinctive banding in it, right? That's metamorphic, right? With these bands like this that are in here, right, where the minerals are lined up, that's a piece of metamorphic stone. You know, so that's kind of a unique piece. You don't find much of that stuff just laying around, but you can see, you know, distinctive layers there. I mean, it's broken down now because, you know, it's rounded, obviously, from being in a stream or being in water for a long period of time, but it's kind of a unique piece. And again, there's that little alligator face, or whatever we're going to call it over there, you know, that's been cut out, dropped off. But as I move through this, right, you can imagine, right, all this stuff that's laying here is not even from around here. You know, a lot of this material came from the north. So, you know, the material that I'm standing on, even though I'm standing on the ground in Rotterdam, I actually legitimately could be standing on Canada. You know, material from Canada. You know, the rock and stuff that was been pushed down by the glaciers and broken down and sent down here from that area up there. So it's kind of neat when you you know, look at geological history in the grand scheme of things, and we talk about movement of material and such like this. The you know, the material has moved a long ways. Obviously, right, this rock, metamorphic, right, not from around this area. You know, this is more like Adirondack stuff, which is where this probably came from. You know, that you know, Adirondacks, you know, somewhere in that mountain area, this material would have come out of. So we know this is not from here originally. All right, well, that's all I have for you today. I'm gonna head back over to my car, and I will, unless you guys have any questions, let me turn my camera around.
I don't have any.
All right, so that was it. That's basically, you erosion and deposition by glacier in this case. So it's kind of a neat spot down here. Most of the time I get permission, but this place I don't know. Like, I don't know who owns it. I mean, I knew who used to own it. It was a construction company, but they've disbanded. So I don't even know if they still own the land or not. But I will talk to you next time. If you have any questions about any of the homework or materials or any of that, please get a hold of me, either by email, or if you want to set up a private Google Meet, we can do that. This is pretty private as it is, but so I will see you next time. I'm not sure where I'm going to be yet, so we'll work on that as I get through the week. I've got some videotaping I need to do down south of here, so I'm going to check out a few more spots. Eventually, I'm going to try to get down. Actually, maybe next time I'll go down to the Cohoes Falls and take a look at that. That should be open, the Falls View Observatory. Last time I was there, it wasn't. So I should be able to get down there and look at that place, and I can show you, some of the power facility down there as well. Because where that section is, there's a section of huge waterfalls that go down through, down towards where the Mohawk kind of goes into the Hudson. And Cohoes has a big section of waterfalls that you can actually go right down to and look at. So I will see you next time.